Okay, now we're going to look at tangents and secants, because this is another commonly occurring trigonometry identities that are in calculus questions. So there are two aspects that you must remember and memorize. The first identity is tan x squared equals to sec x squared minus 1. Okay, this may not be too new for you. You may have seen this in your previous years as well. So if you haven't already done so, please memorize it now. And have a look at the second one. The second one is the derivative of sec x, or the differentiated form of sec x, is simply sec x times tan x, or just sec x tan x. Okay? These two things, you must remember them. So have a look now, and let's try to use them in our questions. So, starting with question 8, find the integral of tan 2x squared dx. So tan 2x squared, that would be the same as sec 2x squared minus 1. Okay, remember our trigonometric identity that I've explained just prior to this? So I've just converted that in terms of sec. Now guys, doesn't this look a bit familiar for you? Remember in our standard integral table, there's sec squared x, okay? Or sec squared ax basically in your integral table. So have a look at that, and you probably can integrate that by looking at that table. Okay, you don't have to memorize that because you can look at it. So have a look at it, and hope you can see that. That's the same as 1 over 2, so basically 1 over that 2 times tan 2x. Okay, so have a look at your standard integrals table if you still don't understand how I got to that point. Okay, so half tan 2x minus 1, the integrated form of that is simply x, and then don't forget your plus c. Okay? Alright, so have a look, and let's move on. So that was pretty simple, wasn't it? Okay, make sure you have your standard integral table next to you and handy, okay? So that's question 8, let's move on. Question 9. Part A says find the derivative of ln sec x. Okay, so we need to find the derivative of ln sec x. So how do we differentiate that? Hope you guys remember that that's simply going to be 1 over sec x, so 1 over that one there, times the derivative of sec x. Okay? And then that becomes 1 over sec x. Sec x differentiated is simply sec x tan x, isn't it? That's the one I've explained prior to this question. Okay, in the beginning. So that's that. I can cancel these out, so I have simply tan x remaining. That's our answer to question 9a. Okay, so if you differentiate ln sec x, you're just left with tan x. Okay, so have a look. Now that we've got that, let's go on to B. Hence find the integral of tan x dx, and it gives us a boundary between 0 and pi on 3. Okay, and basically it's asking us to find the integral of the answer that we've obtained in part A. Okay, so because we can see that that's tan x, we can actually say that tan x equals to the derivative of ln sec x, isn't it? Because that's what we got in part A. So might as well utilize it since it says hence. So the derivative of ln sec x is tan x, so therefore if I integrate that, the integral of tan x dx would be simply ln sec x, isn't it? Because say if I integrate both sides of this one, integral, derivative, they will just eliminate itself out. Okay, so we're just left with the integral of tan x is simply ln sec x. Okay, because differentiation, integration is the opposite way, isn't it? So therefore that's how I got to this point here. So all I need to do is worry about this part. Now I'm going to substitute these values in by going like this. So we have ln sec pi on 3 minus ln sec 0. Okay? So simply this becomes ln 2 on 1 minus ln 1. Basically guys, sec pi on 3, sec is 1 on cos, isn't it? Alright, so first of all, cos pi on 3, that's a half, isn't it? Make sure you remember these values already. So cos pi on 3 is a half, so 1 on cos pi on 3, which is sec pi on 3, that's simply 1 over a half, which is simply 2 on 1 if I multiply top and bottom by 2. Can you see that? So that top becomes 2, Because these cancel, I simply have 1. That's why I just wrote 2 over 1 over here. Okay, and make sure sec 0 is simply 1. Alright. Okay, so now that I've got that, have a look. Let's simplify it. That simply becomes ln 2. Because ln 1 is just 0, isn't it? So I have ln 2, which is the answer. Okay, that's the answer to question 9. So have a look. And that's basically it. So guys, that was it. That was trigonometric functions in relation to our further calculus. Okay, so I hope that wasn't too bad. Hopefully already some of them you're quite aware of. Okay, so when you get to these questions, make sure you can decide whether to use the substitution method, whether to use our double angle identities, or some of these trigonometric identities such as tangents and secants. Okay, so that was further calculus.